Thanks, Heather. And hello, everyone. We are going to start our demo by looking at the Openshift dashboard for the Montreal cluster. And what we see is that there is only one pod running. It's a database. So the cluster is virtually empty. Same thing with the deployments. We see one deployment, and that's the same database. We now shift over to an experimental GUI for the Kubernetes plugin of the ONAP project. ONAP is running in a different data center in University of New Hampshire InterOperability Lab, and the two data centers are connected over SD-WAN. We are going to start the demo by adding a cluster to ONAP. Basically, we're registering the OpenShift cluster. We're going to call it MTL Lab, and we are going to import a settings file to make sure that the OpenShift cluster gets registered properly with ONAP. We'll give it a label, MTL_lab. And next, we are going to create a composite app. A composite app is nothing but an application with several applications underneath it. We're going to call it ngc_mtl. There's a previously created composite app, just ignore that. Now we are going to create an application underneath that composite app. In our case, there's only a one-to-one association. The composite app consists of one application, that's the 5G core. We are going to import the package for the 5G core, which is essentially a Helm package. And now we are going to create placement intent. The orchestration is intent-based. And once we have created the generic placement intent, we can create the specific intent for the application underneath. In this case, we are creating an intent for the 5G core. Now that we have created the service or the composite app, we can deploy it. And this next step is exactly that. We are going to deploy the composite app. So we are creating a deployment intent group. And next, we are going to create a specific intent for the 5G core, where we are going to deploy it onto the cluster with the label that we had previously created. Okay, great. So we've deployed the 5G core. And we go back to the Openshift dashboard. And what we see now is instead of one pod, there are 32 pods there, including all the 5G core services. So the 5G core has come up successfully. As you know, the UPF is a PNF, and this shows you the Kaloom management interface. In addition to the UPF, it shows the entire software-driven fabric. You can see the different interfaces, N3, N4, N6, as defined by 3GPP. And you can see the UPF connected via a set of network elements. In this dashboard, we see more details. We see details of the N3 interface that connects the RAN to the UPF. Now we are going to do end-to-end testing. This is a GUI for a UE and GNodeB emulator test tool. It's called ABot. Now we have another instance of the 5G core running in the UNH lab, and we are actually going to do the testing against that. We are going to run only two tests today. The first test is UE connection request. So that test is running right now, as you see, and it passed successfully. The next test we are going to run is a UE session establishment. So now this test is running, and it's so far running successfully. We are going to see the overall results, 46 tests passed, none failed. And last but not the least, we are going to see a ladder diagram of all the different interactions between the GNodeB and the different CNFs that happened. and how things pass successfully. So this concludes our demo, and now back to you, Heather.